Good afternoon, everybody, and welcome. And I'm glad that you've joined me. And I want to talk to you a little bit about sport and space. I'm just going to share a screen here. And Brenda, maybe if you could just confirm before you disappear that you're seeing my screen and also that you're hearing me clearly.
Yes, I can see your screen and I can hear you clearly. All perfect.
Awesome. Okay. So for those listening, you're welcome to stop me and ask questions anytime you want. But sometimes it's a little bit difficult for me to see who's asking questions. So otherwise, probably what's better is pop your questions into the chat. And or otherwise, when I'm finished, we could talk about those. So we've just finished with the Tokyo Olympics. And you might ask me, what has sports got to do with space? And of course, the answer is they're all physics. So I studied physics. I went up to honors level at university and then took a break for 20 years and then went back and did my master's and my PhD. So I love everything to do with physics. And I think to me, what's important is actually curiosity. Now, this could have been me as a small boy. It wasn't me, but this actually was me. And I think I was busy with a geology experiment or something like that. But I was always exploring the world around me. I was always curious, always wanting to know just how things worked and what was going on. And I think curiosity is really important. My hero in science is Albert Einstein, arguably the greatest scientist ever. And he said this: I have no special talent. I'm only passionately curious. And I think that's awesome. And, you know, Albert Einstein also said, it's a wonder that curiosity survives formal education. I trained as a school teacher, and I know that sadly in many of our schools, probably in most of our schools, there's not a whole lot of curiosity being stimulated. So let me stimulate your curiosity with 4 interesting questions. Number 1, do stars get lonely? Space is called space, but there's a whole lot of space out there. Do stars get lonely? Do they miss each other? We'll come back and answer these. Secondly, how do pulsars spin so fast? Now, of course, first I need to tell you what a pulsar is. So I think you're familiar with this ball on the left here. That's our Earth, our beautiful blue planet. Earth has a mass of 6 million kilograms. So it's pretty heavy. And you know that the Earth takes 24 hours to spin around once on its own axis. We're not talking about its orbit around the sun. We're talking about its spinning. So it spins quite slowly, although if you're on the equator, you're spinning at 1 kilometer per second, 3,600 kilometers per hour. Now, Jupiter is much bigger than the Earth. It weighs as much as 318 Earths, but it actually spins much faster. One spin only takes 10 hours. Now, pulsar stands for a pulsated star. Pulsars are huge, and they have a mass similar to the mass of our sun, and up to 2,000 Jupiters, and yet one pulsar spin takes 1 second or less. Now, how on earth can something so big spin so fast? Well, we'll get to that. You know, the answer lies within the Olympics. Third one, well, I'm fortunate to live on the coast, and I go to the beach almost every day. And of course, we always try to walk at low tide because then there's more beach to walk on, and it's nice and flat, and the sand is hard. So how is it that we have 2 high tides and 2 low tides per day? Because really, we should actually only have 1. We understand that a tide is caused by the gravitational force of the moon on the water directly under it. But then we should only have 1 high tide a day as that part of the Earth passes under the moon. But in fact, we have 2. So that's a bit of a mystery. I hope these mysteries are making you curious. And then finally, can we live in space without gravity? Now, of course, we have astronauts right at the moment on the International Space Station, and they can be there for 6 months at a time, but there's no gravity, and that's not particularly good for those astronauts. So how could we live in space without gravity? Now, it turns out the answers to all these questions and more comes from spinning. And so I'm going to talk about spinning in space, but related to spinning in the Olympics. So if you watch the Olympics, there's some amazing events. We've just had the Tokyo Olympics. They were meant to happen in 2020, but they couldn't because of COVID. So the 2020 Olympics happened in 2021. And if you look at the Olympic 10-meter board, they have the simultaneous synchronous diving two people diving together. They do these amazing twists and somersaults and turns and pikes. And you can see some interesting things that when they want to spin fast, they curl up into a little ball. And when they want to slow down, they straighten out. And so there's a whole lot of interesting physics involved here. You also see it in the trampolining. When they want to spin fast, they curl up into a little ball. And when they want to slow down, they straighten out just like this. You can see it in the gymnastics, in the tumbling. And there's spinning going on around a whole lot of different axes. I don't know how they don't get dizzy. Of course, there's only one athlete here. We understand that this is a composite image taken at various moments during his flight. And again, here you can see one of the female gymnasts doing an amazing dismount. And again, this tucking up into a small ball in order to spin fast. This is Simone Biles from the USA, really the world's greatest gymnast, who sadly had to pull out of the Olympics this year. Now, let me tell you a little bit about angular momentum. And I'm sure you've seen with ice skaters, if they want to spin really fast, they start off with their arms out wide, start spinning, and they tuck their arms in close to their body like this. And that reduces their moment of inertia and they spin faster. Now you can do this experiment. If you sit on a revolving chair, holding two weights out wide with your arms and start yourself turning, when you pull them in close, you'll turn much faster. Now, the real reason is quite a complex one on conservation of angular momentum and calculating moment of inertia. But a simpler way to look at it is you've got to do quite a lot of work to move these weights around through a big circle. Work is force times distance, whereas you've got to do less work to move them around through a small circle. So there's more energy available to speed up your spin. So here's two of the greatest ice skaters, Vanessa James and Morgan Cyprus. And again, they use all of these principles when they spin around. So having talked a bit about spinning in space, let's ask the question, do stars get lonely? And the fact is they don't actually, because most stars spin around other stars. They're just like two ice skaters spin around each other. We find that actually more than 50% of the stars in space are what we call binary stars. They're two stars which are connected to each other by their gravity, just like the Earth is with the sun or the moon is with the Earth. And that causes them to orbit each other. Sometimes these orbits are really slow. It can take them hundreds of years just to go once round. And the gravity between them, instead of them just going off in straight lines, they actually go in circles orbiting each other, much like those two ice skaters. And if the stars are exactly the same size, the center of mass would be in between them. Usually they're different sizes. And so we have a center of mass that's closer to the heavier star, further from the light star. And so they describe these interesting orbits based on where that center of mass is. Now, there's a very famous star, which you can see in the sky tonight, which, well, it was thought to be a binary star. It's actually a trinary star. It's actually three stars going around each other. Now, this is the famous Southern Cross, which you can always see in the southern skies. And these are the two pointer stars. And this star I've circled, called Alpha Centauri, is actually the closest star to Earth. But even so, the light from that star takes an amazing 4.2 years to reach the Earth. Of course, our closest star is the sun, and that light takes 8.5 minutes to reach us. But apart from the sun, this is the next closest star. So that star's light takes 4 years to reach Earth. The next star there, its light takes 525 years to reach the Earth. But to us, they look like they're the same. Now, that star, Alpha Centauri, is actually a collection of three stars. There's two stars orbiting each other and a third star in orbit with that pair. Now, sorry, this is a little bit out of date. The last time I did this talk was the 4th of August. It's now about a month later, but it'll be pretty much the same. So if you look at the southern skies tonight, I'm, of course, looking from close to Durban. You'll see the Southern Cross on its side and the two pointer stars above it. And Alpha Centauri, also called Rigel Centaurus, will be high there. It's really bright, and you could take a look at that. If you look at it with binoculars, you should be able to see that it's actually two stars. Second question, how do pulsars spin so fast? Reminder, Earth takes 24 hours to spin round once around its own axis. Jupiter takes only 10 hours, and a pulsar can take less than a second. Pulsars that take a second to spin are actually called slow pulsars. And there's some of them that take really just nanoseconds to spin around. How can something so big actually spin around so fast? Well, pulsars start off as stars. And this is roughly what a pulsar looks like when it's shrunk from the size of our sun to something that's only 20 kilometers across, really small. Now, pulsars are so concentrated, so dense, that if you cut out a cube of pulsar, just the size of a dice or a sugar cube, that cube would actually weigh more than Mount Everest, would weigh more than 9 billion tons. Can you believe that? Just because it's so incredibly dense. And pulsars initially were called pulsars because they were thought to be pulsing, as if the radio beam was being switched on and off. Actually, it's continuous beam, but you can see that the spin axis and the radio beam axis are different. So a pulsar acts like a lighthouse. Now, you know, if you looked at a lighthouse, you would imagine that the light was being switched on and off, but it's not being switched on and off at all. It's simply rotating round. Sometimes it shines into your eyes, and sometimes it doesn't shine into your eyes. So just like that ice skater who pulls in her hands when she wants to spin faster, a pulsar has shrunk in size when it wants to spin faster. So remember, pull in your arms and you spin faster. Sorry. So a pulsar starts off the size of our sun. It's about 1.4 million kilometers across. And as the star runs out of fuel, it starts to collapse in on itself. It implodes, and it gets smaller and smaller. From 1.4 million kilometers, it shrinks down to about 20 kilometers. That's a huge change in size. And as it shrinks, it's like that ice skater pulling her arms in. It spins faster and faster and faster until it's spinning more than 1 time per second. Incredible. So moving on, and you know, I'm sure you got questions about these. I hope you do. I'm going through things quite quickly, and you can feel free to ask me questions afterwards. So why do we have 2 high tides a day? Because if we understand that tides are caused by the gravitational force of the moon on the waters in the sea, anything that has mass like water is attracted. So why do we have a high tide directly under the moon, but also on the other side of the earth? That's a bit of a mystery. Now, it turns out that we find our answer from the hammer throw. Now, if you've seen this amazing event at the Olympics, they've got a metal ball. I think it weighs about 10 kilograms. Your hammer thrower probably weighs about 100 kilograms, so probably 10 times as much. And he holds it on a chain, spins around as fast as he can. Now, although the ball is mostly going around him, he is also moving around in a small circle. So there's a point probably about here where I'm showing you with the mouse, which is a common center of gravity that they both spin around. Now, it turns out the Earth and the moon are the same. It's not just that the moon goes around the Earth, but that they both rotate around a common center of gravity. So here is the Earth, and showing the bulge of water for the tide, of course, greatly exaggerated. They'd never go that far. Now, it turns out that the center of mass of the Earth-Moon system lies about here. It's about 2/3 of the way from the center of the Earth to the surface. And so it's not just the moon going around the Earth itself is also rotating around that point. So we have the moon's gravity causing this bulge of water on this side, but we have the centrifugal force because of the Earth spinning around this axis, causing the bulge on the opposite side. So we get 2 resultant bulges of water. So a high tide directly under the moon and a high tide on the other side of the Earth, caused by gravitational and centrifugal force. And as I said, our answer really comes from observing our hammer thrower. Hammer thrower would be like the Earth, and the ball of the hammer would be like the moon. And then finally, can we live in space without gravity? And it turns out the answer to this is also by spinning. Now, Wernher von Braun was probably the most famous rocket engineer of all time. He left Germany during the Second World War, went to America, and really helped them launch the space program and get ahead in the space race. And even as way back as far as 1952, so just think that's 70 years ago, Wernher von Braun proposed a spinning space station. So you can see it looks like a big wheel. Of course, it's never been built. The problem would be how to get all the stuff up into space. because it's very expensive to take any sort of payload into space. But he proposed a big wheel which would spin all the time. And because it is spinning, you can imagine here someone inside the wheel, that would cause a centrifugal force which would push people against the floor. So as long as you lived on the outer surface, you would experience something like gravity. And by adjusting the rate of spin, you could exactly match the gravity of the Earth. Now, this is a scene from a famous film, Stanley Kubrick's film, 2001, A Space Odyssey, came out in 1965, the year I was born, and proposed what it might be like to live in space. And the idea is, as long as, again, here we're inside that spinning wheel, as long as that wheel keeps spinning, and you just have to start it spinning because there's no friction in space, people could live and move and plant forests and even have streams, as long as everything is on the outer surface of the wheel. That spinning would push everything down and create an artificial gravity. So I've talked to you a lot about curiosity. Let me show you what curiosity looks like. Now, of course, curiosity is an abstract noun, and we can't really say what it looks like, but this is a Mars rover called Curiosity. Now, there's actually a new Mars rover since this one called Perseverance, which is there at the moment, which is greatly updated. But this one was launched quite a long time ago, and it was named by this young lady. Her name is Clara Ma, and she lives in Kansas in America. And this is a model of the Mars rover. And she won a competition around the whole world to come up with a name for this Mars rover. And I love what she wrote in support of her name. And she talked about curiosity. Listen to what she said. She said, "Curiosity is an everlasting flame that burns in everyone's mind. It makes me get out of bed in the morning and wonder what surprises life will throw at me that day. Curiosity is such a powerful force. Without it, we wouldn't be who we are today. Curiosity is the passion that drives us through our everyday lives. We have become explorers and scientists with our need to ask questions and to wonder." So here she is as a little 12-year-old girl when she won the competition, and here she is graduating from college. I'm sure that Clara Ma has done great things with her life, and curiosity is so, so important because it's what drives us. This is why I still love science. I still love talking about science. I still love teaching science because I'm still curious. I have so many questions about science. And I want to tell you, the more you study science, you find that you have more questions than you have answers. So this is a good place for me to pause and say, are there any questions? I would love to answer your questions. And I'm going to stop my share here. And if you want to ask a question, all you need to do, you can pop it in the chat, or otherwise, what's really nice is if you can switch on your camera and switch on your microphone like I've done and ask the question live. It can be about something I've shown you, or it can be about anything else to do with space. Or in fact, if you have any question whatsoever, let's go for it. Thank you. And if there's no questions, then I'm going to feel like I've done a really bad job because I haven't stimulated your curiosity at all. And just remember, one rule I have is there's no such thing as a stupid question. So come on, now's your chance to ask questions. So Becky, thanks for the compliment on the presentation. I'm sure you must have a question. Come on, now's your chance. St. John's College, Umtata. I can't believe such a great school has no questions at all. Come on, pop it in the chat or ask one live. Don't be afraid.
Derek, what I think we can do is once we've shared your presentation with all the schools, that will be happening in the next 2 to 3 weeks, we will then give them your contact details as well, that the schools can maybe send you emails directly. If there's any further questions that they would like to ask or get clarity on.
Brenda, sorry, I didn't hear that. If you could just repeat it.
Sorry, Derek. Can you hear me now?
I can, yeah.
Perfect. We're going to be sharing your presentation with a lot of the schools within the next 2 to 3 weeks. So what I would like to do is attach all your contact details as well, if you don't mind, that if the schools do have questions, they can contact you directly.
Sure.
Yeah, I think a lot of the schools are very shy at the moment. A lot of people are a bit nervous to ask questions. But yes, I think if they can, then the teachers can relay the message to you directly from the learners.
So I'm putting my email in the chat, and you're welcome to email me anytime and ask a question. I really want to say to anyone who's online and listening, you know, so much of the focus of our school education is pupils providing answers. I've been a teacher for a long time, and I actually value questions far more than answers. And actually coming up with good questions is the way to teach yourselves. And, you know, when you look at space, one must have questions. How many stars are there? Well, I can attempt to answer that. At the moment, we believe that there are about 100 billion galaxies, 100,000 million galaxies. Galaxy is a city of stars like the Milky Way. And we believe the Milky Way has about 100 billion stars, 100,000 million stars. Now, 100 billion is 10 to the 11, if you understand scientific notation. So we've got about 10 to the 11 galaxies, each containing 10 to the 11 stars. So you're talking about 10 to the 22 stars, something approaching Avogadro's number. So 1 followed by 22 zeros, just absolutely infinite. Now, in 1900, scientists thought there were about 1,000 stars out there, so 10 to the 3. So you can see just how far science has progressed. Even in my lifetime, when I was at school, we still regarded Pluto as a planet. We don't regard Pluto as a planet anymore for a number of reasons. When I was at school, my textbook said Jupiter had 18 moons orbiting it. I'm not even sure. I think the current count is about 72. Now, it's not that Jupiter's been giving birth to moons, just that our instruments have got so much better, and we're able to see and detect things better. And I'm sure that number is going to go up, because I'm sure there's smaller moons which we still haven't seen yet. So it's really important to keep asking the questions. And, you know, as I said, there's no such thing as a stupid question. The only thing that's really sad is if you never ask any questions in life, because then it's very easy for people to fool you. So keep asking lots of great questions. Brenda, I provided lots of time for questions. If there's not questions, I'm not sure how to proceed.
Derek, could you perhaps maybe explain what career paths they could follow? And if they are interested in, oh wait, there's another question there from Suzaki. Yes, Suzaki.
But I will do that. Yeah, Suzaki, go ahead. You can unmute yourself.
Hello, Dr. Derek.
Hello.
How are you, sir?
I'm fine, thanks. What's your question?
I also wanted to ask the same question. What are the career fields, career paths in this field?
Okay, you're talking about in the field of astronomy.
Yes, sir.
Okay, so I want to tell you that actually, you know, sometimes living in South Africa, we feel we're a little bit left behind in the world. But I want to tell you, we're not just rugby world champions, we're actually world champions in the field of astronomy at the moment. And South Africa is really the best place to be in the world at the moment. And I'm not just hyping up our country. I don't know if you've heard of the SKA, the Square Kilometre Array, but South Africa won the bid worldwide to build the world's biggest radio astronomy telescope. The receiving dishes combined will have a combined surface area of a square kilometre. Now, we beat off countries from around the world. We're hosting the project together with Australia. We have 60% of the project, they have 40%, and that's going to be in Carnarvon in the Northern Cape. you know, the computer technology needed to analyze the data that will come in doesn't even exist yet. That's how cutting edge this is. So SKA is one opportunity. Also, if you go to Sutherland, also in the Northern Cape, we have SALT, the Southern African Large Telescope, the biggest optical telescope in the Southern Hemisphere. We also have the SAAO, the Astronomical Observatory in Cape Town. We have SANSA, the National Space Agency. It's in Gauteng and in the Cape. I don't know if you know that South Africa has launched 4 satellites. So there are so many opportunities for both astronomy, which is being on Earth looking out to space, and space science, which is being in space looking back to Earth, like through satellites. One thing I have to say to all of you is you're going to need 4 things. Firstly, you're going to need curiosity. Secondly, you're going to need science. So your matric science needs to be really good. Your matric maths needs to be really good. And also you're going to need good English. Now, I know for most of you, English probably isn't your home language, but in order to communicate with the world, 95% of scientific papers worldwide are published in English. So it's really important to have good English. Even students in Japan have to publish their papers in English. So work hard at those 4 things. And, you know, for somebody who passes matric well, there's NSFAS funding available, and there's no reason why you shouldn't go on to follow a career path in astronomy. Just make sure that your science, maths, English, and curiosity are all good at school. Okay, thank you. Thanks for that question. That's great. See, it's not so scary.
Sir, can I also ask another question?
Sure.
So if I want to pursue like a career in astronomy, like which university should I pick, and are there any bursaries that are available to
Okay.
find
You see,
the career that I'm supposed to pursue?
So Zuzake, where are you? What city are you in? Are you there? I just want to find out where you are at the moment. Where do you live?
Pretoria, sir.
Pretoria. Okay. So, you know, being in Gauteng, you're very well placed for at least 3 universities, for WITS, for UJ, and for Tukkies. It's difficult. You know, I work for the University of Zululand. My degrees are from University of Cape Town and UKZN. So, of course, I could be biased. But what you need to do is just go online and do some research. You know, quite often people following a career path in astronomy will start by doing a basic BSc degree, usually majoring in physics, maths, astronomy, astrophysics, that sort of thing. And then, you know, one can always change to a different university, as I did, to pursue it at postgraduate level. So I don't want to recommend one or the other, because I might get into trouble with the universities. But we've got lots of great universities in South Africa, particularly around Gauteng, around the Western Cape, around Durban, but also further afield. You know, University of the Northwest in Mafeking has got a great astronomy program as well. So do some research online, but find a university that's got a strong science program. And, you know, I'm not sure what level you're at now, but if you're in matric, just make sure that for the next 3 months, you do nothing else but work hard and get the best maths and science marks possible. Okay, thank you for those questions.
Okay,
St. John's College, you look like you're keen to ask a question. Why don't you go ahead? Unmute yourselves.
My question is that which university can you go to if you want to like be a scientist or improve in your science?
Okay, again, as I say, to recommend a particular university. Every university, different universities have faculty of science. So again, I just recommend that you do some homework. What you can, of course, do nowadays is you apply to the Central Admissions Office, the CAO. You express what particular preferences you have for study, and the Central Admissions Office will make suggestions or assign you to particular universities. Often it's also a case of which university will give you financial support So you need to do that. As I say, it's difficult for me. We've got many good universities offering good science programs. So it wouldn't be right for me to recommend one over the others.
Okay, thank you very much, Doc. Can I just ask you one more question?
Of course.
Of course. Okay, first of all, please forgive us. Our background is not conducive because we are in a certain corner whereby we're in a school, so I had to organize some few students to attend this.
No
By the way,
problem.
I'm Mr. Mdisha from St. John's College. I'm one of the teachers here who normally produce good results. I'm sure maybe once to our school on national awards. By the way, what can you say, like from your experience, to encourage the student to go for science? Because we are coming from a background whereby the science used to be labeled as those difficult subjects. So most of the learners, including maybe the guidance of the student, they are saying you must stay away from science. How can you just what can you say to motivate them so that they can change their minds?
Okay, that's a really good question. Thank you for that, and thank you for your interest. The thing is that learning anything is difficult. When you learn to drive a car, it's difficult. The first time you drive a car, it's difficult. I've been playing the piano for a long time. When I started learning to play the piano, it was very difficult. Now it's easy. Anything which you learn is difficult. And I think it's really important not just to focus on the matric exam, because I know that people say that the science matric exam is difficult, so don't do science. But there's a lot more to life than matric. And I think, as I said, the real reason for doing science should be that curiosity, that you have this driving passion to understand the world around you. And you're not satisfied with just looking at things or being told how things work. And, we've got some big problems we need to sort out. We have got vaccines for COVID now, but I think we can still develop better vaccines. We still don't have a vaccine for HIV/AIDS. We're still not quite sure what to do when all our fossil fuels like petrol run out. We have a huge problem with global warming. We can't convince people that killing rhinos and taking their horns off is not a good thing. So we've got some big science problems ahead of us. And it's so important to have young people coming through. I'm not going to be the one solving those problems. I'm going to be retiring soon, but it's young people coming through. And I think that the reason one should take science is simply the reason Albert Einstein gave, because you're insatiably curious, because you want to know more about things. And the point is, just give a young person a cell phone. Even though it's difficult to use a cell phone, they will learn to use it because they're motivated. So you have to have that motivation. I also think science, when it's just taught at the blackboard, is really boring. I don't like doing talks on Zoom. I'd far rather do them face-to-face when I could show you some exciting experiments. That's just not possible at the moment. So it's really important, do as many experiments as possible with your pupils. Let them see real science and let them see how that works. Okay. But it's also great that you're joining in a talk like this. I wish more schools had joined in, and it shows that you have that desire to make science real, relevant, and fun for your pupils. Thank you.
Thank you, Doc. One more question from our side. One of my students need to ask one more question.
Can you please
Okay.
and tell us what do you do to improve your science, and if there are programs that you watch on TV, what are the channels that you watch them on?
So can I ask, are you a matric student?
So can I ask, are you a matric student?
No.
What grade are you?
What grade are you?
Grade 9.
Okay. So you can watch television programs. But the problem is most of the programs are made overseas, and they're great programs, but they're not particularly relevant to the syllabus. Let me say to your teacher, I've put my email address in the chat, and if you contact me by email and you give me the address of your school and give me an idea of how many pupils you have, I've developed a wonderful series of videos to support matric science. And because you've taken the trouble to log in today, I will send you a box of books for your matric students and the videos which you can use to promote science in your school. I'll do that with pleasure, free of charge, because SASTA is also supporting us in what we do through the programmatic funding. So please email me, get my address from the chat. Email me, give me your contact details, and I will send you a lot of material. But again, I think the thing is just simply to be curious, just always to be asking the question, why does that happen? Never to be happy with just watching things go by, but always wondering how things happen. And so, and I think that curiosity in the long run will actually feed your matric science marks far better than just doing endless revision, even though that is important. Thanks. Please go ahead. Anybody else who'd like to ask a question? So if you're curious, maybe you can ask the question, how is it that there are two of me here? How is it possible that there are two Derek Fishers? And maybe which one is the real one?
Zoom is always great fun, Derek. I thoroughly enjoy what we can do with Zoom and what we can't do with Zoom, but it's always challenging and the learners are learning a lot from it. I think I'm going to then, if you are happy, close the session here. Obviously, we are concerned about data and all that type of thing. I think it's one of our biggest challenges with what we're doing here. If you could all please complete the attendance register that's in the chat box at the moment. In there, we're capturing all the school addresses, the emails, the contact details that I can then forward to you as well, Derek. So please, St. John's College, complete the attendance register form so we can send you all those details and that Derek can forward you the books that he's so gratefully given to you guys. I think it's wonderful. Derek, today's been absolutely fantastic. Thank you so much. It's really been great listening to you today. I think maybe quickly to close off, where are the best sky viewing sites in Umtata and in KZN? I see that's where the two groups are joining us today. Yeah,
well, the great thing about the sky is it's everywhere, isn't it? So you don't have to go anywhere, except you need to go away from bright lights. So the worst place in South Africa to look at stars is Johannesburg, just because there's lots of bright lights. So I'm lucky. I live in a very small town called Umtunzini, and so when I go outside, even close to the lights of my house, I can see the Milky Way in the sky. But basically, you need to get away from bright lights. You need to get away from pollution. Obviously, if there's clouds, you're not going to see anything. And it also really helps if you can get a bit high up. So from my point of view, I quite often give star talks in the Drakensberg. There we have the advantages. There's not much light. We're high up. So there's less of the atmosphere above us. There's no pollution. And although it's a little bit chilly, we can really see the stars well. I think in South Africa, probably the best place is Sutherland or Carnarvon. And that's where they've sited the two observatories, specifically because those are good places. But you can view the sky from anywhere. It helps if you have a clear view to the north, because that's where you can see the planets. And actually go and have a look tonight, because there are 4 planets up in the sky. If you look in the west just after sunset, you will see Venus and Mars. And if you look in the east, you will see Jupiter and Saturn rising. So it's really special that you can see 4 bright planets in the sky tonight.
Fantastic. Thank you, Derek. One last opportunity for questions. Anybody want to ask anything else? Okay, then on that note, I'm going to say thank you, everybody, for joining us this afternoon. It's really been fantastic. We do have another a recorded session we'll be doing at 2 o'clock.